Newton's first law of motion states that an object at rest stays at rest and an object in motion stays in motion with the same velocity unless acted upon by an unbalanced force. Here in this experiment, we can see that Newton's law of inertia is in motion, where the car is in motion but stops as a result of an unbalanced force, friction, acting upon it from the ground. Additionally, by also considering gravity and the car's own mass, the car must have stopped at a sooner time and distance than the original anticipated distance if friction was the only force being applied. Newton's second law of motion is where the net force is equal to the mass of the object times the acceleration. Conversely, the acceleration is equal to the net force divided by the mass of the object, and the mass is equal. The practical we did to prove Newton's second law was using a ticket timer and ticket tape and the trolley. We let the trolley roll down the slope while connected to a ticket taper, showing its acceleration down the slope. The method of calculating the average acceleration would be to find the final velocity and initial velocity and divide by time. To get the initial velocity, we must divide the distance between the first two dots and divide by 0.02. And for the final velocity, we divide the distance between the last two dots and divide by 0.02. This shows the second law because we can use the mass of 600 grams of the trolley and acceleration calculated to get the net force acting on the object, which will mainly be composed of gravity. Newton's third law of motion states that for every action there is an equal and opposite reaction. Here in this experiment we can see that a ball is being bounced up and down. This demonstrates that an action entitles an equal and opposite reaction through the ball on the ground. When the ball hits the ground, the force of gravity's potential energy is acted upon it. Therefore, the ground also pushes on the ball with the same reaction, forcing it to go back up. However, since the ball also has a mass and there is air resistance, the ball would not bounce back the same height as its original projection.